With this lesson, I'm going to do the entire lesson here. We're going to be solving quadratic equations, specifically using the factoring method. We've covered some other methods as far as doing it on the calculator, as well as the quadratic formula. Some methods are quicker than others. Factoring is a very popular method. It's very, very quick and easy once you get some practice on it. So we're going to kind of go through the entire lesson on this one and show you how it's done, hopefully help you out a little as far as your understanding on it. So let's kind of get started here. You're used to this equation here. I want you to go ahead and try this one. At this point, you should be able to solve this one already. So go ahead and push pause now, and whenever you're done, go ahead and push play. Those of you who are drawing a blank at this one, if you remember, what we're going to do here is we're going to set this x minus 2 equal to 0. Then we'll do x plus 3 equal to 0. We find out that our answer is x equals 2 and x equals 3. X equals both of those values. X equals negative 3, excuse me, both of those values. All right, now you try these two. Go ahead. Check your answers here. You ended up with fractions on both of these. X equals negative 1/3, and if you wanted to write that as a decimal, it would be 0.333 on down the line, depending on where you ended up rounding. And the second one would be negative 3/7. And fractions are okay. There's nothing wrong with that. Fractions are exact numbers, so we don't ever have a problem with having fractions. On some of the homeworks, I do require that you round it, so you want to pay attention to what I ask you to round it to. But otherwise, fractions are just fine on the tests and so forth. All right. Now, if I asked you to find the x-intercepts, now in this course, we've already talked about y-intercepts quite a bit, and that's where it crosses the y-axis. The x-intercept, something very unique occurs at the x-intercept. Well, if you think about it, the y-intercept, x value is 0. So on the x-intercepts, that's where your y value is going to be 0. All right, so it's basically the same thing. It's as if we have this h of x, which is also equal to y, if you want to think of it that way. If that equals 0, so we're going to do the exact same thing. We're just setting both of these up where they equal 0. We're just going to solve it for x. So go ahead and do that. We'll walk you through each one. But that's really all it is when I ask you to find the x-intercepts, that's where the y value equals 0. And that's kind of what you've been doing all along, is to find where the x-intercepts, find the value of x. You find out that x equals x equals negative 3 and 8. So the x-intercepts, remember your y value is 0. So it's going to be an ordered pair, negative 3, 0, and 8, 0, both in parentheses. You see how I have it listed here. The axis of symmetry on this one. Now, if we remember the axis of symmetry, in order to find that, what we're going to have to do first is to find the vertex. Once we find the vertex, it's the x value of that vertex. It's x equals whatever that is. That will give us our vertical line. Now, to find the axis of symmetry here, we would either have to go ahead and multiply these out, FOIL them out, then plug it into our formula, negative b over 2a is my x value, and then plug it in to find y, or you can just plug it into your calculator just like this. Do it with your y1 and put it in parentheses 3x plus 9, close parenthesis, then open parenthesis, x minus 8, close parenthesis. Put that all in as y1. Then you can find your axis of symmetry there too on your calculator, and that will work just fine as well. Hopefully those of you who did it were able to find that your vertex was 2.5, comma negative 90.75. So that's the vertex. The axis of symmetry is going to be x equals 2.5. Okay, again, that is whatever the x value is. That is your answer there, but it's got to be a vertical line, so it's got to be an x equals. X equals 2.5 is a vertical line right at 2.5. 2.5 would not be an acceptable answer because that's just a number. We're looking for a vertical line, an axis of symmetry. Vertical line that divides that parabola right in half. All right. Now, you can do all of those using your calculator. I would highly recommend doing that. It's going to be a lot easier than trying to do it by hand. You can do it by hand, though. You would just have to multiply those two together and then plug it into your formula. All right, so now here's what I want you to do. I want you to find the x-intercepts, the vertex, and the axis of symmetry. And remember, when I say x-intercepts, those are brand new. That is when your y value equals 0, or in other words, solve it for x, if that's what you want to think about your shortcut. Go ahead and do that. push pause now, and when you're ready to come back, go ahead and push play. Okay, so hopefully you found out that you had your x-intercepts here. You had two different ones, -6, 0 and 2, 0. Your vertex was -2, -32, and your axis of symmetry, remember, is x equals -2. All right, for the next one, hopefully you found the similar ones as well. Again, you can see your vertex and your axis of symmetry. That's where we got the axis of symmetry, is right from our vertex. But x equals -9, so it's -9, 0. That's my x-intercept. Now, if you were to graph this on the graph, you will see that it crosses right at -9, 0. Right at that point, it will cross the x-axis. Same thing with -1, 0, both in both positions. Okay, now let's get into some factoring. Now that we know the easy way to do it, let's get into some factoring and solve some. Just a quick refresher on factoring. This is x squared plus 3x plus 2. And remember, we've got, this is our standard form, what we call standard form for quadratic, ax squared plus bx plus c. Remember, what we do when we factor is we need two numbers that multiply together to give you c, but add together to give you b. So c here in this case is 2. So I need two numbers that multiply together to give me 2. That would be 2 and 1, and -2 and -1, both of those work as well. Then it has to add together to give me b, and I know that b is 3. So which one of these, when I add them together, is going to give me 3? And this is a +3. You'll notice this, the addition sign here. So that's going to be 2 and 1. So now when we break these apart, it's going to be x plus, see, that one doesn't work, so x plus 2, x plus 1. Okay, the x value comes first. This is the factored form of this original quadratic expression. All right, so again, two numbers that multiply together to give you c, but add together to give you b. You put whatever the variable is. In this case, it's an x. You put that first. All right, so let's go through here. I'm going to have you factor both of these two. Go ahead and push pause now, and when you get your answer and obtained it, come on back and push play. Check your answers. So I've got an x minus 2 times x minus 2. Some of you may have written this one as x minus 2 squared. That's okay. That's acceptable. And then down here we have a -10 and a +3. And the order does not matter. So if you wrote it as m plus 3 times m minus 10, that's okay. That works too. Commutative property of multiplication says that it doesn't matter what order it's in. So we'll be okay there. All right. Now I want you to actually solve these. But I want you to solve them using the factoring method. And it gave you a hint on this first one. I already factored it. Remember, two numbers that multiply together give you -12, but add together to give you -1. That would be a -4 and a 3. So now that we have it here, we've been solving a couple of these already today. Go ahead and finish this one, and go ahead and do this next one as well. So push pause now. Whenever you obtain your answers, then you can come back and push play. Check your answers here. And hopefully we're getting used to our factoring form. Once we have it factored, then we set them both equal to 0 and solve it. Hopefully that's not an issue. Sometimes I see students go x equals -4 and x equals -3. Or x equals -4 and x equals 3. Because they're taking these numbers. But you forgot that you have to set it equal to 0, then actually solve it. In order to solve this one, we would have to add 4 to both sides. That would give me a +4. That's a common error that we usually see. So make sure to pay attention to that portion. All right, so we want to solve by factoring. Try this one again. Go ahead and push pause now. When you're ready, come on back and you can push play. Check your answers here. Should have had -9 and 2 for your x values. Now, those are your x values. If I asked for the x-intercept, that would be -9, 0 with parentheses around it, and 2, 0 with parentheses. But I'm not, I just asked you to solve it. When I ask you to solve it, that's just -9 and 2 are your answers there. All right, now let's get some more in depth with factoring. This one, the factoring that we've done in the past, if you'll notice here, this was the previous one that we did. All of the factoring that we've done has been with a leading coefficient. That's the one way out in front of the x squared, has always been 1. That makes it really easy there, but now we're getting into ones in which this leading coefficient is no longer 1. Now there are several different ways you can do this. The decomposition method, you got a couple other ones as well. I'm going to demonstrate today the Berry method. And the Berry method is, most students find it to be easier. It's got a couple quirks to it though. So you need to be aware of those quirks, and we're going to kind of go through those. But most students find this to be much, much easier than any of the other methods that we do. Not always exact, but it gets you about 90% of the time, and the other ones that it's a little bit off on, when you're going to solve them, it's right 100% of the time. And that's the purpose of factoring, is to try to get to a point where you can actually solve these. So let's go through this. Okay, the very first thing that we need to do here is we're going to write this. We're going to factor this into two binomials. So two binomials, and the very first thing that we're going to write down is 10x. And we haven't filled in this second portion here. Now, this is the quirkiness with this one. We know that this is wrong, because if I were to multiply these two together, 10x times 10x would give me 100x squared, not 10x squared. So we already have too many. We know that this is wrong from the get-go. We're going to fix it later on when we go down just a little bit. So just be aware of that. We know that this is wrong. As we go throughout the method, it'll hopefully make a little bit more sense to you. Okay, now what we have to do, now that we've got those two written down, we need two numbers that multiply together to give you a times c. Previously, we've done just c, but now we're doing a times c. And technically, when you did it earlier, you did a times c, but a was always 1, so 1 times whatever c was, so you just took your c value. So it's really the same thing here, just a little bit more in depth. So we're going to take a times c, 10 times -1. Two numbers have to multiply together to give me -10, essentially, but add together to give me b, and b in this case is -3. Okay, so multiply together to give me -10, but add together to give me -3. So two numbers again, -10 multiplying, and if we add them together, give me -3. Hopefully you can find out as you do a little bit of work there that it's -5 and 2. Now that we know that it's -5 and 2, I'm going to take these and I'm going to fill in my slots here, whatever I have left in my binomial. And order does not matter here. And that sounds weird, but both of these have 10x. So it doesn't matter if you write 10x plus 2 here, then 10x minus 5 over here. That's okay, that works too. Order does not matter, because both of them have the 10x there. So now that we have this one, remember we had too many to start. 10x times 10x gave me 100x squared. We know that that's wrong. So we're going to go back in and fix it here. So what we're going to do now is see if they have any common factors. So in this binomial here, this one has two parts. We call that a binomial. In this binomial, we're going to factor out any common factors. So between 10 and -5, 10x and -5, I can factor out a 5. So if I factor out a 5 there, that's going to leave me 2x minus 1. Okay, that's the same thing. You always know if you factor it correctly, if you can multiply it back and have it equal what your original one was. Well, 5 times 2x gives me 10x. 5 times -1 gives me -5. So I know I did that one correctly. All right, now I look over here and I go 10x plus 2. Are there anything in there that we can pull out that are common factors? Indeed there are. There is a 2 that we can pull out. And if we pull out a 2, that leaves me with a 5x plus 1. Now remember, if we're pulling out a 2 here, that we were left with a 1. That 2 doesn't disappear. Now, this is the part that gets a little bit crazy, really quirky, is that these parts that we just factored out here, we cancel those off. We cross both of those off. They're gone. They're dead to us. Now, that seems weird that they just magically disappear. And sometimes they go away and sometimes they don't. Typically with this Berry method, they will almost always go away. A couple times they won't. We'll kind of get into those later. Now, what we need to always make sure we do is this factored form here always has to equal what this total one was that we started with. Okay, so let's look at this. 2x times 5x gives me 10x squared. 2x times 1 gives me 2x. -1 times 5x gives me -3x. So if I add those two together, -5x and positive 2x, that's -3x. And then -1 times 1 gives me -1. So these two are actually the factored form of that one. So that is it. That's as far as we go with it. And it's a little bit weird because we're crossing these ones off, but we started with too many to begin with. And so when we start with too many, we're going to have to eliminate some. If you remember right here, we had 10x and 10x. Those multiplied together give us 100. Well, that was 10 too many, okay, because we're going to multiply those two together. So when we factor those out, these two multiplied together, 5 times 2, is 10. So that's where our 10 came out of. But the big thing here is that you always have to remember whatever your factored form is should be able to be multiplied back together, FOIL these together if you want to equal your original quadratic expression. All right, now that one was fairly confusing, brand new to most, so I'm going to actually do another example of a similar one. All right, now on this one here, same rules apply. The very first thing that we're going to do is write down 4r in both of them. And we know that this is wrong from the get-go, because 4r times 4r gives me 16r squared, not 4r squared. But we'll pull out the extra later. So now what we're going to do is we're going to go a times c, two numbers that equal a times c, but add together to give me b. So while a times c, 4 times 15 is 60, and b is 16. So I need two numbers that multiply together to give me 60, but add together to give me 16. Those two numbers are 10 and 6. Now, it doesn't matter what order you write these in. I wrote them in this order, but again, you could have gone 4r plus 10 or 4r plus 6. Doesn't matter. Now, we're going to go back over here to this one on the left first. Is there a common factor we can pull out here? 2 is a common factor here. So I'm going to pull a 2 out here. That will leave me with 2r plus 3. And this one here, we've got a 2 again as a common factor. So I'm going to pull out the 2. That leaves me with a 2r plus 5. Now, what we pull out, we're actually going to cross off. Those are gone. And this is the final factored form. And you'll know that it's correct because you can multiply these two to get your original quadratic expression. So 2r times 2r gives me 4r squared. So we know we're right there. We can do the rest of it and find that out as well. All right, so now let's get a little bit of practice on this one. I want you to go ahead and factor both of these. So push pause now. If you need to, rewind just a little bit and you can kind of see what I did. Maybe that'll act as a guide for you. But go ahead and push pause now. When we're ready, come on back and push play. Check your answers on these two. So again, whatever we factored out was crossed off on all of these. Okay, all of them, they went away. There are a couple instances in which they don't go away, but again, we'll get to those later. So for right now, if you can cross those off, you'll be okay. All right, I want you to actually solve this one by factoring. So we're going to take it an extra step further. In other words, I want you to factor this first, then go ahead and solve it. I want to know, for number 1, what x equals, and number 2, what n equals. So go ahead and do that. Push pause now. Factor those first, then actually set them both equal to 0 and solve them. Check your answers here. Both of these ended up with fractions all over the place. And again, hopefully you were able to factor out the common factor, cross those off, then actually solve it correctly. You end up with 2 different fractions on the first one and 2 different fractions on the second one. But if you did that correctly, just double check your work here to make sure that you got the correct answer. You can also graph these on your calculator to see where they cross the x-axis. And if you'll do number 1, you'll see that it crosses at 1.5 and at negative 0.4. That's the decimal version of those, but that would be where it actually ends up crossing. So we've got this one here, and if I asked you to solve this one by factoring, we have done this one previously. This is one of the example problems we did. But if you want some extra practice, go ahead and pause it now, and you can go through the problem and actually try to solve it. But I'm going to go ahead on with it now. You ended up with this one being 1/2 and negative 1/5 if you solved it all the way. Now, graph that one. Take out your calculator. Plug that equation. When I say plug that equation, plug this original equation right here into your calculator. And let's see where it crosses that x-axis. Now, if you look here, I zoomed in a little bit. You know, if you're going 10 by 10, a lot of times it's a little bit hard to see where this one crosses. But this is negative 0.2 is where it crosses. And over here, it's 1/2 is where it crosses. So if you zoom in enough, you can actually see that. That is where it crosses the x-axis. So if I asked you where the x-intercept, it would be 1/2 comma 0 in parentheses, and then negative 1/5 comma 0 in parentheses as well. All right, well, that concludes this lesson. You'll want to go back and review any portion that you need to get a little bit more practice with these.